So next up, we have Mr. Chung Shin Yee, our Senior HPC Analyst at NSCC. But unfortunately, he's unable to join us today, so I will do the presentation on his behalf. And before I begin, I think I should do the same introduction for Shin Yee as well. So Shin Yee has more than a decade of experience working on custom software development and HPC software parallelization and optimization. He was involved in the development of a wide range of software applications, including graphics rendering systems, tomography, data processing using GPUs, and iris/face/fingerprint recognition software. So Shin Yee is in the working group of the ASPIRE 2A system. He leads the NSCC software team to build and manage HPC applications on the ASPIRE 2A system. So he also runs the HPC benchmark and to evaluate the system and application performance. So I will do the presentation on his behalf. So let's begin. His work, as well as partly mine work as well, is to work on the HPC application benchmarking and performance evaluation. We also do the HPC software support, and as well as the ASPIRE 2A system and HPC software builds and installations. His interest is in the parallel algorithms for multi-core CPU and GPU, cache performance optimization, and adaptive scheduling algorithms. So these are Shin Yee's interests, not mine. Okay, so I think Paul shown the same slide just now. Never mind, we go into the details. So we have the same PBS Pro as ASPIRE 1. And we also support Singularity and Kubernetes, which the group will cover later on. And as mentioned, we have two parallel file systems, which are the GPFS and Lustre. And unlike the ASPIRE 1, which uses the CentOS 6, now we have the Red Hat Enterprise Linux 8.4. Okay, so this is a good news to many people who are unable to build their software due to the aging OS on the ASPIRE 1. And yeah, for development, we have quite a few options to choose from. We have the AMD AOCC, which is written by the AMD. And also we have the GNU. And also we have the HPE Cray Compiling Environment and Intel, as well as the NVIDIA HPC software environment package. Okay. So we have the CUDA, we have Go, we have Python, Java, Julia, Octave, R, if you want to do some programming in these languages. For MPI, we have the Cray MPICH and also partly support OpenMPI as of now. I will show the details later on. We also have several options for the scientific libraries. The AMD AOCL, the Bliss, Cray LibSci, FFT-WGSL, NTMKL, and PetScience. And of course, we have the I/O libraries, the HDF5 and NetCDF. For profiling and debugging, we have more options when compared to ASPIRE 1. So you have the ArmForge, the CrayStat, GDB for HPC, PerfTools, and Valgrind, which is for HPC in this version. And for the rest, these either is part of your workflow or you use it as your main software. We have the bio tools. We have this is the workflow. I think these two are particular to a unified model. And also for AI, we have TensorFlow, PyTorch. And for simulations, I believe this is for the DFT people, this is for the biologists, and maybe some material scientists, LAMS, and others, yeah, the CFD software, this is also another CFD software, this is DFT, this is the weather. And we also built some application and tools. I think FFmpeg is one of the video generator for LAMS, which can be used in the output. And of course, others which are, you can explore them yourself. So we have the Cray Programming Environment. ASPIRE 1 is not a Cray machine, so now it is a Cray machine, so there are certain things that you might need to get used to. One of them is the programming environment. So by default, the Cray Programming Environment, the PRG-ENV Cray will be loaded by default. You can switch to others by doing the module swap. You can use the Intel or GNU, whichever you prefer to build your software. And currently we have this, the set 1 of the Cray Compiling Environment, which is one of the latest version, which is the version 13.0.2, and also the corresponding Cray libsci FFTW. This is Cray FFTW, the HDF5, and the NetCDF. So our software modules and organization will be in a simple to understand format structure. So it's just /app/apps/lamps/23rd June 2022. So this will be the format when you do the module load. Let's say module load lamps. So you will get this, the software are located at this location. And the same for the libraries, okay? As well as the containers. So these are the singularities containers, which can be found at the apps containers. And we also have the /app/environment to support your conda and Python environments. Note that this is work in progress, okay? So, yeah. Okay, so currently, this is what is shown on ASPIRE 2A when you type module AV. So this is not the final list, of course. We will add or remove software based on the requirements or the feedback from the users. So you can see LAMPS, Julia, OpenFOAM, Python. I think Paul also mentioned that we already have built 83.3% of the top 20 applications from ASPIRE 1. And also we have the, some of the library module files here. Okay. Okay, so this is on the topic of MPI. This is the OSU benchmark from done by Shin Yee. So he compared the performance of Cray and Pitch versus Open MPI, which some of you might use. In this slide, I think the performance is rather similar. And the point-to-point latency versus the message size is also quite similar. Unfortunately, the all reduced latency does increase with OpenMPI when when the message size is between maybe 4K to 256K. So do note that the message that Shin Yee is trying to carry out in these 3 slides is that as of now, at least for now, try to build using Cray and Pitch if possible. So we also have the MPitch ABI, the application binary interface. Shin Yee he has tested the ABI built with the container. So it is possible to build HPC software in container with these, the ANL MPitch. So you can try it out, let us know. Yeah, I think that's it. Any questions from anyone?